This podcast was brought to you by Meros Cryptocurrency. Meros is a cryptocurrency payment system that does what cryptocurrency originally intended to do. Be a practical and secure form of direct payment, Meros utilizes the best of current technology in a powerful new way. It introduces a groundbreaking consensus mechanism called merit caching. This enables Meros to be both feeless and instant while maintaining the same level of integrity of traditional networks like Bitcoin. To find out how you can participate in the future of crypto payments, go to meroscrypto.io now.
Hello and welcome to the July 2020 update of State of the Project Meros. I am your host Cryptosi, and this month I am joined by the mercurial developing talent that is Kayaba. Kayaba, good evening sir, how are you?
I'm doing great, as always. Happy to be back here. I think there's going to be a lot to talk about from this past month, so I'm very excited.
Yes, there is. There's a lot to talk about. But before we get into that, let me just let everybody know what this podcast is all about. For those of you that have been living under a rock, what we do each and every single month, and we have done for almost 2 years now, is we go over the development of this brand new cryptocurrency that has been built from the ground up, which is a hybrid of... No, actually, do you know what? I'm not even going to go into the technical details because I know I'll get them wrong. And Kayaba will shout at me. But it's a very...
You've always done great covering it in the past.
Thank you. All right, let me butcher that then, and tell the listeners that So what Meros is it's a hybrid of a proof of work / proof of stake DAG type network. Is that right, Kayaba?
On a simple level, yes. Of course, unlike using Dash... Oh, wait, no, Dash proofs of work. I don't know why I thought they were proof of stake for a second. Unlike PivX or similar proof of stake coins that are... like Peercoin was the original one, of course, where we use random selection of someone who put a certain amount of money up. Meros is our cryptocurrency. We have a second token called Merit, which you earn by mining the blockchain, and this is used to vote on blocks. So we don't have the infinite loop of you enter money to make more money. We have you mine the blockchain, contributing proof of work security, and then use the mine token to vote, which then actually earns you the currency Meros. So via this, we gain a lot of the benefits of both proof of work and proof of stake, and allow using both systems to remove the detriments of the other. Yeah.
I think I prefer it the way I said it, but yeah, I do understand that you're the expert here.
You do have the much more friendly and approachable version.
Thank you. That's 2 compliments in 2 minutes. We are on a roll. So this month we have plenty to get through. Before we start, also, I wanted to congratulate you on getting your mojo back, because we had 2 barren months on the trot, which actually are probably the only 2 barren months that we've had so far. So a lot of people were worrying that you had lost your mojo, but evidently in this July update, it's clear to see when I was doing my research, the GitHub is back on fire. So congratulations. The first issue I wanted to speak to you about actually even included myself. I even made a cameo appearance in the GitHub. I will put the link in the description. But it was an issue number 194, which I believe was marked protocol. So it wasn't critical, but it was quite important, I guess. Well, we'll soon find out. And the issue said that Meros should use LE instead of BE. I commented on this because I didn't know what LE or BE was, and I was quite upset that you had abbreviated it and cut me out of the loop, basically. So could you explain to us what is LE, what is BE, and why should Meros use one over the other?
Right. So we've actually, I believe, talked before about the accessibility of GitHub issues to people who aren't developers, because you believe that GitHub, traditionally marketed as a platform for developers, that's still their tagline, should be open to everyone. And that's something I kind of agree with. Not sure we've discussed it on the podcast, but I did appreciate you commenting, because even for a developer, the way I phrased it may have been missing some context, and it is important to keep other people in the loop. So LE stands for Little Endian, and BE stands for Big Endian. Basically, when a computer stores a number, there's two different ways it can store it. So if we look at base 10, what most humans use, in fact, everyone does unless they're working with computers. Let's say we have 100. The number 100 is stored as 100. Now, a computer, if it's using big endian, it puts the most significant byte first. So the most significant byte or number in 100 is going to be the 1. It's the one with the most value, because it's their hundredths place, 10th place, and ones place, and that's the hundredths place. So, but little endian actually does the reverse. Little endian says 001. And of course, this is in binary. I'm trying to refer to the number 100. But so this is something that's always frustrated me. Little endian has become the standard for computers and for networking. And the reason I don't like that is just because it goes against human nature, to say the least. So therefore, I've always just personally preferred big endian, and I built Meros with that in mind. That said, little endian is just the standard from internal computer architecture to networking to cross-compatibility. So as much as I prefer big endian, there's no true way I can justify keeping it in the protocol, as it will solely create a conflict instead of an advantage, or it's basically a difference based on personal preference that doesn't have any pluses or minuses either way, except for the fact it's different. And because of that, that can serve as a detraction in the long run. So basically, this issue was just about flipping it. It's not that big of a deal when it comes to effectiveness. It's just trying to make Meros more accessible to new implementations.
It's interesting how you've described that, because I didn't know what the situation was before you explained it on GitHub. But why do you think that they have decided, or why do you think it's caught on that people are using little endian as opposed to big endian? I guess there is, when you're programming, you never program from right to left. So why are computers expected to read in that direction?
So it's actually twofold. So there's some actually interesting programming things behind it. One of the things you can do in programming languages is bit manipulation. So a computer number, let's say it's made out of 8 bits or 1 byte. It's the most simple type of number you can have. So you have 8 bits of 1 or 0. You have 8 1 or 0s, and via any combination of these, you can get up to 256, because there's just 256 possibilities contained there. So when you want to move bits over, say you have a bit in the second place, and you want to move it to the 4th place. When you do this in a programming language, of course, since this is on the bit level, big endian and little endian only applies to bytes. So this is a microscopic quick view of it. But in programming languages, all representations of numbers when it comes to the developer actually are big endian. Like if you say move left 10 bits, it will do the big endian move left of 10 bits. So even programming languages acknowledge that big endian is the friendlier way. That said, when you're building a computer, when you're building a CPU, that CPU is built in one of two ways. It's built in big endian or little endian. It's not built to do both. So if we look at CPU architectures over the years, the most popular one is now, or at least for powerful computers, laptops, desktops, so on. But of course, there are a lot of servers and phones coming up. But when we look at laptops and desktops, we generally deal with a platform called x86, or specifically x86-64, which is a 64-bit version of x86. And then as we look to phones, we see ARM devices. And even Raspberry Pis and now some supercomputers are also using ARM. And Google, a few years back, moved a lot of their server infrastructure over. And there's also a new architecture coming out, which I've been personally keeping an eye on, called RISC-V. And that is another. But all of these, the core attribute between them is they're all little endian. So of course, there's a lot of other similarities and a lot of differences. Each architecture has its own reason for existing. But effectively, every CPU in use in the world today has accepted little endian as the way to do it. And I personally don't actually remember the reason why. I believe there is some argument for it, like when it just comes to simplifying the internal CPU, like when they're developing the CPU, for some reason, little endian is just easier to work with. But because it's the default for every CPU, it's become the default for networking.
Okay.
So even though programming languages represent numbers in big endian, where you're doing some manual manipulation just because it's easier, it's just the way computers have gone. So computers have gone one way, humans go a different way, and programming languages offer to provide a bridge. But in the end, I went for personal preference over the network protocol, but that can block off some accessibility, and it's just going to be better for everyone who wants to interface with the protocol just to use Little Endian.
Yeah, so what are you thinking that when outside developers come in and start to work with the software, they're going to anticipate or expect that everything is working in the Little Endian format? And that's the reason why you didn't want to use Big Endian.
Right, but it is important to note that when we talk about Little Endian, we're only talking about numbers. We're not talking about hashes or public keys or private keys or anything like that. We're literally just talking about like the amount, well, even the amount of outputs are 1 byte. So Endianness doesn't affect single byte values. So we're really just talking about like Meros amounts, like balances in the protocol. Just when you create a transaction and you say send 5 Meros to this person, that may be one of the only things affected by this change. I mean, there's a couple of other things, but we really already don't have a lot of Little Endian, Big Endian code because it's really just used with the most basic type of numbers. And most numbers we do don't go past 1 byte. Just because when we're dealing with transaction outputs, there's no reason to have more than 255 outputs within a single transaction. So anyways, this affects very little the protocol, and we've very frequently documented that we use Big Endian. But even if it only slightly helps, due to how small the change is and how large the ramifications could be, I just figure we might as well conform.
Yeah, okay, fair enough. The next one I wanted to move on to is it's a big one, so I think we're going to take a while with this one. It seemed to develop into a huge saga, so let's take it step by step. Locked Meros isn't implemented, and that was issue number 183. I believe it was marked as critical. I'm just going to double check. I believe it was marked as critical. But could you explain to us what that issue was all about? And no, it's a bug actually. What that issue was all about and how it came about and how you plan to fix it.
If I recall correctly, it's both listed as critical, bug, and protocol. Oh no, it's listed as feature, not critical. My bad. So
yeah.
Locked merit, not Meros. So as we discussed earlier at the very start of this podcast, merit is what you earn from mining the blockchain, and it's used to verify transactions and establish yourself as a figure on the network. And there's actually a lot of reasoning behind it, which I'll try to skip past here. But one of the features Meros has is where a merit holder, if they go offline, theoretically, if enough of them go offline, transactions would stop instantly verifying. For a transaction to instantly verify, according to the Meros node software, it needs over 80% of the merit to agree on it. And it cannot have any competitors in play. So if anyone tries to create 2 transactions at once, Meros is like, no, I'm not going to bother with this. If someone's trying to cheat the system, then I'm not going to be polite and instantly verify it. So as we look for 80% of the verifications, that means if 1/5 of merit holders over a year, because merit lasts for an entire year, if 1/5 of them goes offline, we'll no longer be able to have instant verifications and the whole system's going to slow down. So locked merit says if a merit holder goes offline for roughly an hour, the math on it is a bit dependent on timing, but it's really just 1 hour to 2 hours, they get their merit locked, which means it still exists. They are welcome to rejoin the system, but it's no longer being considered for votes. And because of that, if 20% of the merit holders go offline, we're now not dealing with 80% of 100% of the merit. We're dealing with 80% of 80% of the merit. So it just means that the system can keep on going, even if merit holders slowly drop off over time. And if those merit holders restart their nodes because they want to start contributing to the system again and earning Meros, then they start creating verifications. And eventually, as they create verifications, their merit will become unlocked after about another hour, and they'll be able to start contributing to the system again. So it's something we've extensively documented in the protocol before, and it's a really big feature that I've been putting off, and it's one of the main blockers to our next testnet and next testnet and next testnet. So it's finally something that I've been getting around to implementing, and I just wanted to create a tracking issue for it. Generally, when it comes to protocol breaks, like Meros has yet to implement part of the protocol, I don't create an issue for it because we generally have the protocol divergences extensively documented in the protocol docs. But this was a large enough feature with enough things going on. Since I was actively working on it, I wanted to track it. And while working on it, I had to revamp the Python test a bit because it changed kind of the behavior of the entire network, where, merit holders can now get locked. So any Python test, which we use to fully test the node, we actually have a re-implementation of Meros in Python.
We're going to get onto that. We're going to get onto that later. But yeah, go ahead.
So any test that used more than 2 hours worth of blocks was suddenly having different behavior, just because we implemented locked merit, which changed the behavior of merit. So I actually had to rework a lot of the Python tests for this.
Going back to, or slightly staying on the same theme, another thing that you did realize, or that did crop up, was issue 204. In issue 204, sending a verification packet with no holders is causing Meros to crash, believing that there's an infinite key. Now, the first part of the comment, which I have to congratulate you. I know I do this every month, but I really like the way that you document your thought process and what's happening actually in the GitHub, so that us non-developers can get in there and read it, sort of like a Harry Potter book. And it said you found this while working on number 183. So during issue number 183, you found this new issue, which is actually critical, as well as being a bug. It's actually critical. What is this problem that verification? Well, it's kind of self-explanatory, but if you could give us a bit more information on it, and how do you intend on fixing it?
So when implementing locked merit, we had to edit the Python test to basically make sure that merit didn't become locked. That's what we were editing all those Python tests to do. So that's done by just having a data transaction, which just stores some data on the network. We create one every 6 blocks, and we just verify it. So every 6 blocks, a data transaction appears, and every merit holder in the system verifies it so they don't switch over to locked. And of course, some tests are going to want to switch merit holders over to locked to test locked merit. That's the whole point of it. But these tests, which don't rely on the behavior, they just make sure that they maintain it unlocked, so on and so on. So while working on this problem, something interesting appeared. While working on the merit removal test, merit removals are penalty actions. So if a merit holder is malicious, they're removed from the system. So when working on the merit removal test, Meros was complaining, hey, you submitted a verification packet, and this merit holder that's part of it doesn't have any merit. They just had a merit removal, so it's invalid. So then I had to work on making sure if a merit holder does have a merit removal, they're not still verifying the data transaction that appears every 6 blocks, because that's going to be invalid. So I wrote that code, and then when there was only one merit holder and they just had a merit removal, it was still generating a verification packet. It just didn't have any holders attached to it. And Meros said, okay, all of these holders have merit because there's none of them. And it tried to verify the signature of it. And when it tried to verify the signature of it, it combined the public keys, which were none. And when you combine no public keys, you get a 0 public key. You get one that's blank. And according to BLS, the signature scheme we use, the system we use for verifications, a 0 key is called infinite. As in, it's all zeroed, and that's considered infinite by the system. It's just something there. It's just part of the math involved.
Yep.
So then there's an infinite key that it's trying to verify against, and it's like, this can't be right. This just can't be right. We should not be here. Something truly is wrong. Let's shut down the node. Let's not try to continue acting. Because if it continues trying to act on invalid data, it's just going to get worse and worse. You can't have an issue like that and ignore it. It's just going to compound and compound. So we just shut down the node at that point. Of course, by shutting down the node, that technically is crashing. Because it's a very controlled crash. We do on purposely shut down, but it is shutting down the node unexpectedly. So basically, it's just we accidentally created a verification packet with no merit holders attached. Meros tried to handle a key that was made out of no keys, which was all zeroed. And according to BLS, the signature system we use, a zeroed key is infinite. And when it realized it was trying to operate off an infinite key, it said, this can't be right. I'm going to shut down.
So is it the Meros equivalent of divide by 0, which is something that computers often struggle with?
This podcast has been brought to you by Rhubarb Media. Rhubarb Media are the branding specialists behind successful crypto projects such as PivX, Vendible, and Libertaria. The Rhubarb style is both loved and respected the world over. So if you want your project to appeal to techies and everyday users alike, give Rhubarb Media a try. You cannot possibly be disappointed. Link is in the description.
Right, so of course in math, divide by 0, there's just no answer for it. You can say the answer is 0, you can say the answer is infinity, you can say the answer is original number, and it's not something solvable. You can have a lot of answers, but yes, it crashes a computer because the computer just can't generate an answer that doesn't exist. And this is kind of similar in that we're trying to get an answer out of something that doesn't exist.
So do you feel that this is at all fixable, or is it something that you have to go a step ahead to fix the actual causes rather than try to fix what happens when a node thinks that it's got an infinite key?
So I already correct the Python test to never generate this case again. That said, The problem is with the Python test, anyone can manually craft a network message that causes this behavior and get a node to shut down, which is obviously a huge problem. So whenever we detect a message that's invalid like this, we just need to raise an error and say, hey, this message is invalid. We really shouldn't be trying to handle this. And it's a simple enough fix. I was just waiting until I finished the locked merit before moving on to it, because as we're not running any networks, there's no reason to rush it. But it does have to be done before we do the next network.
Yeah, okay. And it does say here that you've added this to developer testnet 5.0, which I guess we'll speak about later in the class. New contributor. There's a new contributor to Meros, a guy or maybe a girl by the name of RikuBlock. They've been helping with these Python tests that we've been speaking about. Well, Python virtual environment. Let me not get ahead of myself. It may not be tests, although it probably is. Who is this new developer and where did you find them?
Right, so one of the things I've talked about recently, I'm not sure it came up on the podcast, but it definitely came up on the server, is that recently I finished some contracting work. That was one of the reasons we had 2 barren months, one because I was personally moving and one because I was getting some funds ready for both myself and the project. And using those funds, I created some bounties. I created some tasks that anyone is welcome to do and they're welcome to get paid for it. And RikuBlock responded to a few of them. And a couple very nice things. One of the things they did was upgrade our Python tests to, I just have my own test runner. It was okay, it worked well enough, but it was a bit clunky. And they were polite enough to move it, of course, for a bounty, not trying to deny that, over to a framework called PyTest, which is the standard for Python testing. And then beyond that, they also implement threading. So this means we can run multiple tests at once. Instead of waiting for one test to complete and move on, we can run 4, 8, 12 of them all at the same time, and it really makes running them faster. And when they completed those bounties, they also did something called virtual environment. There wasn't a bounty for this, they just thought it would help out, and they were happy to help. And virtual environment is a Python program that just says, hey, you're doing multiple Python projects, and for some reason these Python projects may not like each other. One may require package version 1 and one may require package version 2, and package version 1 is not version 2. So unless you want one of these to break, you need to have 2 separate installs. So virtual environment creates a dedicated Python install, dedicated package set, and so on. So you can ensure that the virtual environment will not conflict with anything else.
Okay.
So it just really makes the Meros Python test more accessible to anyone who has existing Python projects up and running.
Awesome. Oh, great. Where did you actually advertise these bounties? Where can people go to find out about bounties for Meros?
Right, so I'm on a couple development servers where I posted them on a personal level, and I may have made an announcement about one or just the fact that we had them. But if you actually want to look at the open bounties we still have, I've been hosting them on Gitcoin. Because despite being an Ethereum project, I'm not someone who says Meros is going to kill Ethereum, Ethereum's stupid. No, I really respect all cryptocurrencies that do well in the field. And Ethereum is the premier smart contract platform, and I honestly really respect their development. So Gitcoin just allows me to post a decentralized bounty. I can put up cryptocurrency, and anyone can respond and be confident that they'll receive the funds from it. So I've just been doing them through Gitcoin.
Awesome. Okay, brilliant. My final question, I believe, unless something else crops up, is a commit, or the most recent commit, I believe, and it was to fix the protocol violation. But it was a commit which you posted called to fix a protocol violation. I'm assuming it wasn't one that we've spoken about so far today because you've fixed it and those were open issues. So what was the protocol violation that you did fix? And are you happy with the state of the protocol at the moment?
Right, so I'm actually very happy with the protocol. We do have a couple issues open to editing the protocol, but generally when we talk about protocol violations, we're not discussing problems in the protocol. It's something I've extensively gone over the process of months. Generally I'm saying the Meros node software, it's still a work in progress. It's still missing some features. It still has some kinks to work out. So one of the things we did is we had to sort a list of numbers. It's not a complicated task, but we still had to do it because depending on how the list of numbers is, you'll get differing results on differing machines, and we need to maintain consensus, make sure all nodes on the network come to the same agreement. So there are two ways you can sort numbers, lowest to highest or highest to lowest. Meros did highest to lowest, and yet the protocol specified lowest to highest. It's kind of like the big Endian versus little Endian thing again. Sorting lowest to highest is the standard. I personally prefer highest to lowest. There's no real need to be a contrarian. Sure, it's a bit more human readable, but this is the protocol. It's not really meant for humans. As long as developers can understand it well enough to work with it and debug it, it's really for machines to machines. So basically, I just had to go through the calls in which we sort data and just make sure that it sorts it lowest to highest instead of highest to lowest. After I did that, I just had to update some of the data that depended on. We have a lot of generated data for a Python test. We don't mine the blockchain every time we run it. We already have a pre-mined blockchain to just speed it up a lot. It's one of the things I'm very proud of. So we just had to update the already built data sets to use the new sort algorithm.
Okay, so I looked through this at the time, and the thing that jumped out to me was in the consensus document, there was a key line. Well, I don't know if it was a key line, but it spoke to me anyway, which stated that Meros does not support chain reorgs. Now, that line was deleted and replaced with Meros doesn't support the... No, hold on. No, it was just deleted. It wasn't replaced with anything. Sorry, my mistake. It was just deleted. Now, does that mean that Meros now does support chain reorgs? Is that something that is brand new, or is that just a little bit of cleaning up of the document and Meros has been supporting chain reorgs for a little while? Because I know we spoke about it, but I think it was about 5 or 6 months ago we spoke about chain reorgs. What's the situation now?
Right, so we've supported chain reorganization since before the last testnet. If I actually go into my testing directory, just 1 second, and I pull up the reorganization set of tests, I can actually see the history of when I added them. So it's at least been a few months. Unfortunately, I moved them around a bit, so it deleted the history. It didn't delete it. I would just have to look further for it. Right, so we've done it from before the last testnet, and the last testnet was 2 months ago. I'd say we have chain reorganizations as long as 4 months ago. It was a problem I just had yet to get around to, yet it was really critical, not only for network stability, but for testnets and so on. It's one of the fundamental underpinnings of any blockchain. So, yeah, I just realized that when I was going through the protocol, that I left the note in there, and the note was no longer accurate, so I figured I'd just delete it real quick.
Yeah, because that's probably my fault. I think I've missed the trick there, because I do remember we did speak at quite a long length about chain reorgs, and if my memory serves me, I'm going to go out on a limb and say it was December of 2019. I'm going to say it was in the December update of 2019 we spoke about chain reorgs. But I guess we'll go through the old episodes at a later date and you'll prove me wrong. But I think it was in December. Okay, so I wanted to move on. And finally, last question is, what's happening with the Meros GUI? Has there been any progress on that? How are things looking on the front end?
Right, so we've actually had the GUI for a while. The key thing is that we have yet to bridge it over. We have all the files for it. It renders. It looks good, in my opinion. And I just actually have to drop it into the Meros node and make sure all the bindings are in place. You have this one piece here, one piece there. We just need to hook up the wires. And it's just something I have yet to devote time to, and it's something I really want to get done before the next testnet, just to make Meros a bit more user-friendly and see how long we can get this next testnet going for. Previously, the problems have been chain reorganizations, and then there was a new problem with syncing new blocks
Yep.
that we recently fixed. And now we're working on locked merit. So even if testnet participants go offline, the network doesn't stall. So yeah, the real testnet, I'm hoping to get it going for a few weeks.
So you're hoping that I guess it's been dubbed testnet 5.0.
Yep.
We're not going to add a S for stable onto that one, are we? We're just going to leave it at 5.0 for now.
If it's unstable and I want to add a stable version, maybe then. But hopefully we'll be stable from the get-go.
Okay, and we're hoping that in that one, we're going to have a Meros GUI that we can all have a little tinker with.
Right.
I'm going to put you on the spot. Have you got a date for the next testnet?
So we actually do have a milestone for it on GitHub, which I can pull up now. And the milestone basically says, here's all the things I want to do before then. Right, so if I go over to milestones, sorry, I'm just pulling it up now. The milestone, I'm still adding a few issues to it as it pulls up. Right now it's about 20% done. The main things that I wanted to add to it are, I don't think all of these issues are going to remain. A few of them are just low priority. You know, I added them because they should be small enough to do it in time, but they're not something that are really critical for this next network. Right, so developer testnet 5.0, the main things are, one, linking over the GUI, locked merit, fixing the verification packet bug we were talking about earlier with the infinite keys. And then there's just a bit of chain reorganization cleanup I want to do. So yeah, locked merit is the biggest feature, but after we do locked merit in the GUI, we should be almost there. And I'm hoping to have locked merit done within the next week.
Okay, so we're assuming that developer testnet 5.0, I can actually ask you questions about how it's going or how it went by the time we do the next podcast.
Very hopefully so.
Awesome. Excellent. Just for everybody listening, I've also will put a link to the developer testnet 5.0 milestone. Probably by the time you listen to this, by the time we release this, we're hoping to get this released really soon and early in July. By the time you hear this, the testnet may not be running yet, so you can watch it being developed in pretty much real time, watch the things be ticked off as they go, because it goes from open to closed, just letting the non-developers know how it works. Even though I know you don't like non-developers snooping around on GitHub, I can tell you from experience, it really is an awesome resource. Even if you do not know a word of code, you can still get so much good information from it.
My complaint isn't with making GitHub accessible. I would love for more people who aren't developers to be on GitHub. My complaint is what I see your view for GitHub is, which is a combination of Instagram, Facebook, and maybe 10% code. You might want to leave 10% code in there. But also maybe some forums about what the best place to, just throw your Meros up in the air like Scrooge McDuck and dive into it is.
Yeah.
So while I want GitHub to be accessible, I don't want it to become social media.
You know what GitHub really could do with is more pictures of our pets. That's what we could really do with more on GitHub. I think that would make it. Do you want me to start
photographing every meal I take and adding it to the Meros repo?
Exactly.
Just with the best burger.
Exactly that. So we can add to the issues. We can add weight gain and our partner's bad habits. Right. Last question. I ask you every month. I am even feeling like we're getting super close now. Now that I've heard that the GUI will be ready to be used. When mainnet? Kayaba, when mainnet?
So one of the things I like to do is I like to keep track of the big features blocking Meros, because there's plenty of small bugs, and if I wanted to, out of the 34 open issues we have, if I wanted to, I could probably get about 10 of them done in a week. It's just not worth the week of time at this point, because while they do have to be done eventually, there's just more priorities going on right now. So if I actually pull up the main list of features we're still going through, locked merit is really the big one, because we've already done chain reorganizations, and that probably took a month or so. And that was one of the biggest features. And now locked merit is one of the biggest features. So if I just go through the issues real quick to see, or the protocol docs, because again, we do list what we have yet to do in the protocol documentation. The other really big feature, there's only two other really big features after that. One of them is called checkpoints. So checkpoints are done every 6 blocks. And it basically is just a way for people who already have merit to make sure that people who are just earning merit via proof of work stay in line. So now if you want to perform a 51% attack, you have to get every block for 6 months. And the existing merit holders, have to keep an eye on it. And of course, it's an automatic process. I'm not saying they are supposed to manually intervene every 1 hour. I'm just saying it allows a bit more checks and balances between the miners and the old miners who are currently managing the system via proof of stake. So there's that one feature called checkpoints, and the only other big feature is something called Meros script. So Bitcoin attaches a script to every transaction. It's a small little program that says who can spend the transaction. So with Meros, we don't attach scripts to every transaction. It's honestly a waste of space and a waste of computing resources, in my opinion. That said, we do have a transaction called lock and unlock, which allows you to store a small program on the blockchain for purposes like atomic swaps and so on. And that's the other big feature that we have yet to really work on.
You want those definitely done before mainnet?
Yes, those are essential. The mainnet will just not be good without it. There's just no way I can be happy about launching the mainnet, because some of these are actually critical to security and functionality.
Right. Okay. When we go off air, I'm going to get directions to these protocol documents as you're describing them, because I think it might be useful, because I can't find them.
If you just go on the Meros GitHub, there's a folder named docs, and under docs, there's a folder named protocol, and that's just all the protocol docs.
Yeah, that's where I am, but I can't see the ones that you just mentioned. And how do I know which ones are finished and which ones aren't?
So all of those are the up-to-date protocol docs. We have some issues describing how we want to adjust them, but these are flat out the up-to-date protocol docs. So while they're not finalized, so if you want to make finalized synonymous with completed, then they're not completed because they're not finalized. That said, these are complete documentation that detail every feature we want to work on right now. And of course, the issues do describe some tweaks that need to be made, but these really should be trusted as the source of documentation. So if you go to the merit protocol documentation or the transactions protocol documentation, there you'll see at the bottom, you'll see the violations that I'm talking about, where violations just mean any slight differences to any inaccuracies to any incompleted features.
Right. Okay. Okay. Gotcha. So then these violations are kind of like a checklist towards implementation. Once all of these are gone, then we can consider it fully implemented.
Right.
Okay. Gotcha. Right. Okay. So I will link those in the description down below for anyone who's listening. Absolutely fascinating set of documents. We have covered them. I think we've been covering them from like episode 2. So thank you for that. I hope you can't hear my dog in the background. Right. So finally, I just really wanted to thank you for giving up your time again this month and being so concise and succinct with your answers and your explanations. Is there anything else you wanted to speak about before we left?
I just wanted to say your dog sounds like a very sweet puppo. I'd love to meet them sometime.
He's been absolutely silent all day long, and then now that he knows that I'm doing a podcast, he wants his 5 minutes of fame.
I've had to be cuddling with my dog this entire time so he doesn't start barking. He gets so upset whenever I talk to someone over the microphone. So I'm just giving him... Yeah. He's a very sweet boy, though. He's just a bit old, likes some attention.
Yeah, I know exactly what you mean. Right, thank you so much, Kayaba, and congratulations to everybody who's listening. You have reached the end. Thank you very much for your time, and please don't forget to like and subscribe. It really does mean the world to us. It helps us to get our reach a little bit further. We're going to be back in August with the next update. Hopefully, we'll be discussing Developer Testnet 5.0. I may even myself have a go now that I know there's a GUI, because command line makes me nervous. And Kayaba, once again, thank you, and we'll catch you all in August. Thank you very much.
Thank you so much.
This show is brought to you by PivX Private Instant Verified Transactions. With its groundbreaking zero-coin staking and masternodes, PivX is the top privacy currency. Feel free to trade some on Binance or Bittrex. And for more information, go to www.pivex.org.